Now we have to find the area of the base. When we look from above, the cylinder and sphere, when they intersect, they form one circle. Okay, so this is circle in the xy plane. So we will draw that circle. Okay, this is our x-axis and this is our y-axis. So this is the circle. Here we have converted into polar coordinates, so we will consider one ray starting from this point and ending on this point. So the lower end of the ray is r equal to 0 and upper end of the ray is on the circle. And equation of this circle we all know is nothing but ra cos theta. In our case, in cylindrical coordinate, we do not have theta, we have phi. So its equation is r equal to a cos phi. Okay, so these are the limits of r and we have to cover this entire region. So we will move this ray from this point till this point, that is from this point till this point. Here theta is minus pi by 2, so phi will be minus pi by 2 and we will move till phi equal to pi by 2. So these are the limits of r, these are the limits of phi, and these are the limits of z. So now if you clearly observe, we have covered only this part, that is upper part. We have covered only upper part, but we also want the below part. So we multiply our this equation of volume by 2 and then we integrate. Okay, so these are the limits only for upper half of the common area. To cover this entire volume, we multiply by 2. Okay, so now our new equation will become, we put x equal to r cos phi, we put y equal to r sin phi, and we put z equal to z. So when we put z equal to z here, we will have I equal to 2 times integration. Phi is going from minus pi by 2 to pi by 2. R is going from 0 to a cos phi. And z is going from 0 to z equal to root of a square minus x square minus y square. So x square minus y square, from these two equations, when we add x square plus y square will be r square. So from this equation we have a square minus, I am taking minus sign common, so I will have x square plus y square. So this term will become root of a square minus r square. So this will be nothing but r square. Then we have z square, so we keep z square as it is. Then we have dx dy dz, and dx dy dz we used to substitute it as r dr d theta d phi dz. So instead of dx dy dz we will have r dr d phi dz. Now concentrate only on this integration. So we have integration phi going from minus pi by 2 to pi by 2, r going from 0 to a 2 times, and z going from 0 to root of a minus r square, z square r dr d phi dz. So now if you see here, z in limit contains r, so first we will integrate with respect to z. Okay, r, when we integrate first with respect to z, r is constant, so we can take r here, so we will have r. And integration of z square, what is integration of z square? It is nothing but z cube upon 3, and here we apply the lower limit of z and upper limit of z into d phi. Now we will put the upper limit minus lower limit. So when we put z equal to a square minus r square root of a square minus r square, we will get a square minus r square root the whole cube, because here we have z cube. When we put z equal to 0, this entire term will become 0. d phi dr, and these terms will remain as it is. So our integration will become 2 by 3 integration of phi going from minus pi by 2 to pi by 2, r going from 0 to a cos phi. Here it should be a cos phi. So r is going from 0 to a cos phi. Then we have r into this term. So we have r into root of a square minus r square the whole cube dr d phi. We can write this term as a square minus r square the whole raised to 3 by 2. Okay, so here we have r into this term. Let's say we consider f of r equal to a square minus r square. The derivative of a is 0 minus 2r. So f dash of r is minus 2r. Here we already have r, so we multiply and divide by minus 2. So this term will now become f dash of r, and this term is f of r the whole raised to n. In our case, n is 3 by 2.